Hello, and welcome to Learning to Fall. So I'm Rafael Ordog. Most people call me Devil. And what I'm going to talk about is microservices. And actually, it's a bit more ahead of the curve in the terms that microservices was a hype, and now it's more like then we had this disillusionment phase, and now this talk is about how microservices can go wrong and what you can do about it. Well, at least one aspect of that. But let's start with the background. So remember the monolith? Who remembers the monolith? Right? All of us remember the monolith. And those were great days because whatever we did, once it was in production, it wasn't our problem anymore. It was an ops problem. So we could just throw things over the wall and everyone was happy. And then there was this guy called Jeff Bezos who said, you built it, you own it. And then everything just turned, well, quite unpleasant, to be honest, at least for us developers. So we came up with the idea of microservices. Because if we have microservices, then we don't have to deal with deploying the entire application. We just deploy that one microservice. And if you think about it, what were monoliths? I have a pretty good metaphor for that. Yeah. Now, once you take a monolith and break it up into microservices, you know what it turns to? Yeah, little piece of shit. But I'm not being completely fair here because the honest picture is like this. Your own service in the middle is a polished gem. It's always perfect. It's always other people's services that fail, right? So that's the world that we are living in. It's always the other steam crap that fails. So what can we do about it? Well, so my wife is doing martial arts, and one of the things they teach people at martial arts classes is how to fall gracefully, how to fall in a way that you don't break your arm. Okay, and this is really important because if you are in a dojo, then people are going to throw you around, and it's gonna hurt. And if you don't fall correctly, you might break your neck. So it's pretty important to learn how to fall well. So that's what I want to teach you now, how to fall gracefully when other services are not as nice as your own. So I'm going to talk about, so this talk is going to be in 3 parts. The first part is the journey, how we realize that we have to do something about this issue. Then I'm going to talk about the enlightenment, when we realize how we can deal with these problems, and eventually, if we have time, I would like to dig a little deeper. So let's start with the journey. Let's imagine we have a car rental company, and we have a very simple application. There is one process, one database, and the process is making queries to the database. That's the simplest application you can imagine, right? This is essentially a tiny monolith. And what happens is when we want to reserve a car, we check if the car is available, then we reserve the car and assign it to a customer. These are the 3 steps that we are going to do. These are 3 separate queries. Now, this sounds good, but at some point, the boss comes to us and says, hey, some cars have been reserved, but no one picked it up. So we scratch our heads and wonder what might have happened. And then we look into the logs and we see that, yes, the application correctly checked that the car is available. Yes, it correctly reserved the car. And then when the assignment should have happened, something went wrong, network was down, and we couldn't assign the car. So essentially we had a reserved car with no one to pick it up. So this is bad. How can we fix that? Any ideas? How would you fix that with SQL? you would use transactions, right? You start a transaction, you do your thing, and then commit the transaction, and that makes sure that the whole transaction is atomic, either everything happened or nothing. That's the cool way to do it. Okay, but now something happens. This car rental company buys a bunch of other companies, and it becomes a travel agency. And they have like 3 different systems, and those systems have to talk to each other. They offer these kind of travel packages that have a car in it, a hotel, a plane ticket, and even museum tickets. So essentially, you have to organize 4 different services with 4 different databases, and you have to deal with that. How do you do that? Well, it's not as easy anymore because it's not one service, not one database. And that's just one problem. The other problem is that the transactions that we are doing, even if it was just one application, that when you do a transaction, it locks things in the database, and that can have an impact on performance. If you have like 20 or 30 queries that run in sequence, and maybe some of them are long queries, then doing a transaction is going to put a performance impact on your application. And also, if it's not even the same application, like in our example, then a transaction is not even possible, because you cannot say MySQL to lock, you cannot ask MySQL to lock rows in a PostgreSQL or even a MongoDB. MongoDB doesn't even have transactions. So what you do about that? Because we have several databases and multiple services. Yeah, so one idea, the worst idea that you can come up with, is fire and forget. You just make the queries, and if some of them fail, you don't do anything about it. Don't do that, because you will have inconsistencies in your database, and you end up with the same situation that we talked about, where the car is reserved but not assigned. Okay, what's the next idea? Maybe we can do manual failure recovery. So what you would do there is you create logs, and whenever there is a failure and you couldn't complete an operation, then you make a log, and then you create PagerDuty alert that alerts you in the middle of the night that something is wrong. Now that works for a while, but you will be pretty angry sometimes when you have a lot of failures and you can get your job done because you have to manually fix the database all the time. And after a while, you will be pretty sleepy because waking up at night to fix a database is not really fun. So what's the next step? Well, maybe we can automate that recovery. So we don't have to wake up anymore, but we can say, okay, if there was a failure, then this other script runs and it tries to fix things the way we would do it manually. That's somewhat better. But what kind of automated recoveries can we think of? My first idea and my team's first idea was brute force. So whenever a query failed, just repeat it a bunch of times, like 5 times. And hopefully it will succeed at least once. So there are a number of problems with that. So one thing is that even though you retry it a few times, it may not be successful. But what even worse is that you might end up sending a lot of queries to the database, and after a while the DB just falls apart under you, and you have like this runaway thing where the more queries you are sending to the database, the worse shape it is in, and then you just overload the database much faster than you would otherwise. So okay, that's not good either. Okay, next idea. Distributed transactions. Okay, so at this point we went on the internet and tried to find what other people did, and we found out about distributed transactions. And the way distributed transactions work usually is a 2-phase commit. Two-phase commit means that you check every query if it could run, but you don't commit them. Basically, you open a transaction in every database, you do your stuff, and whenever all of the queries are successful, then you commit all of the databases one after the other. Can you see the problem with that approach? Exactly, the committing part may fail. So yeah, that doesn't work either. Uh, and we haven't even mentioned scalability issues, because if one of the databases has a long-running query, then we keep transactions open in several databases until that one database finishes. And also, there is a single point of failure, because whenever our process dies before the commit or halfway through the commits, then we have again an inconsistent state. So these are the things that we tried, and frankly, none of those worked really well. So then we had the enlightenment. What can we do? What's the correct way of doing it? And the interesting part is that we came up with this solution ourselves, and then after that, I went to a conference and heard someone talk about it. So it turns out that there's nothing new under the sun. And the solution that I'm going to tell you about is actually a really old solution. People came up with it in the 60s and 70s when they had large and slow disks, and the solution actually works nowadays with microservices as well. So the idea is, what if we don't stick to ACID? Do you know what ACID is? Okay, can you shout out the words that belong to the letters? A is atomic, exactly. C, consistency. I, isolation or integrity. Some people say it's integrity, but it's isolation. And D is durability, exactly. So one of those things will go. And my challenge for you, while you're listening to this talk, try to find out which one is gone. Okay, so what's the solution? The solution is called the Zaga pattern. And the original purpose is not to make sure that your microservices work together nicely. The original purpose was to break up long-running transactions. So their problem in the old days was that the queries ran slowly. So whenever they had like a bunch of queries in sequence, then having all that logs live while the whole transaction runs was too expensive. It had a performance impact. So the idea is that I want to break up my transactions into smaller pieces. And the nice thing about this approach is that, by the way, it also solves your microservices issue. But that's completely coincidental. People didn't design it for microservices, but it works really well, so why not use it? So what's the definition of Zaga? And actually, I have the definition here. Zaga is a sequence of independent actions with idempotent compensating actions. So I like these definitions that usually professors give at the university, because no one understands them. So let's just break this thing down so that we understand it better. So what's a sequence of actions? Well, an action is that I reserve the car, for example, and I have a sequence of these actions. That's easy. What is a compensating action? Compensating action would be something that I do, and if I do that, then I get back to a state that is equivalent to the state that I would have gotten if the original action wasn't done. So, for example, I reserve the car, and then I cancel the reservation. That's a compensation action, the cancellation of the reservation. The important part is that you want to make sure that it looks like this never happened. And the difference from just reverting that action is obvious when imagine if you are incrementing a number, okay? So you are incrementing an integer one by one. So I do the incrementation, and then some other processes do something else with that number, and then I revert. I do the canceling action. If my canceling action is to write the original value into the database, that's not a compensating action because all of the things that happened in between are also cancelled. I just want to cancel that incrementation. So instead of just rewriting the original value, I will just decrement the value. Does it make sense? Okay, so that's really important. And what does idempotent mean? So idempotent means that if I do it twice, it will have the same effect as if I did it once. Incrementing an integer is not idempotent, for example, because if I increment it twice, then it will be 2 times bigger with 2, right? So what's the definition of idempotence? An operation is idempotent when applying it multiple times is equivalent to applying it a single time. So again, that's like this professor kind of definition. And I used to have a really good example for this. What's idempotent and what's not. And when I did the talk in Hungary, everyone was laughing. And then I did the talk in Germany, and people walked up to me and said that this was offensive. So I'm not going to say that example, but yeah, instead of I came up with another example which is not as funny. But imagine that you have a cup, and someone tells you pour a cup of orange juice into the cup. Then you pour it, and you're done. And then they tell you to pour again. Then you pour again, and it overflows. So pouring the orange juice is not idempotent. Makes sense, right? But if someone walks up to you with a cup of orange juice and tells you to drink it, and you drink it, then the cup is empty. And if they tell you to drink it again, nothing happens. You just have 1 cup of orange juice in your stomach. Okay? So that's idempotent. That's the difference between being idempotent and not being idempotent. It's idempotent if you do it twice, you have the same result. So let's look at the saga pattern in action. First, I'm going to show you the happy path. The happy path is like this. So here is our travel agency example. This other guy is our service, and he walks up to this lovely lady and tells her that he wants to reserve a car. And the lady says, all right, let's reserve the car. Then he walks to the hotel guy, asks to reserve the room. They say, okay. And then we walk to the plane or the air, sorry, to the other company and ask for a plane ticket, and it's okay. So for now, that looks much like brute force, right? We just do all of the queries, all of the actions, and we just go through it. But what happens when we have a failure? And that's the interesting part about the Zaga pattern. First, we reserve a car, and the lady says, okay, it's reserved. And then we walk to the hotel guy, and they say, we are full, we cannot. Besetzt, right? So now we have a problem. We have a car reserved, but we don't have a hotel. So we walk back to the lady and say that we want to cancel the car. And if we were lucky, then the lady would say, okay, the car is cancelled. But in this case, she fell asleep. So what do we do? Well, we ask again. And the lady wakes up and says, what? And then we repeat again, and then she says, okay. So this is why we need idempotence. Because when we do the cancellation, we might end up in a situation where it's not successful. So we want to be able to repeat it as many times as we need to. Okay? And then if we say again because we are angry and we didn't hear her say okay, then she can just say, it's already cancelled, don't worry. Okay. So what's the Saga guarantee? The Saga guarantee is that either everything is successful by the end of the saga, or the successful events are compensated for, or we are in the process of executing the events. And now I'm going to ask you, what was it that we lost from acid? Exactly. We traded off atomicity for availability. That's the main concept here. So now we know how the Zaga works. Let's dig a little deeper. And let's look at how to implement a Zaga pattern. First, we will need a Zaga execution coordinator, which I'm going to call a SAC from now on. And the SAC is going to do a bunch of things, but this is the part of the code that is responsible for making sure that the Zaga is either completed or it's in the process of being completed. And for the SAC, we also need a Zaga log. The Zaga log is going to be persisted, and we are going to go through the Zaga log when we need to revert actions. So just as an example, we have our travel agency there, and then we have the hotel, car, and the plane service. And then what we do is first we are going to wait. Yeah, that's not what I need. So first what we are going to do is we are going to begin a saga, and we will write into the saga log that we began the saga. That's the first log item. Then we begin reserving the hotel. We do our transaction with the hotel service. When it's successfully returned, then we write into the Zaga log and hotel. Begin car. We do our thing with the car service, and so on until everything is reserved and we are happy. So that's the happy path. What happens if there is a failure? Then what we will do is we begin the saga, begin hotel and hotel. That was successful. Then we begin car, and when the car service returns an error, then what we are going to do is we are going to write abort Zaga into the Zaga log. And if there is an abort Zaga in a Zaga log, then the only thing you are allowed to do from that point on is revert everything before it. So after the Zaga is aborted, we never ever try to complete it. We just try to do everything in, try to compensate for everything that we did before. And in this case, what we do is we begin undo car. We try to talk to the car service, and if it's not successful, we try it a bunch of times. Exponential backoff is a good idea here. So if the car service doesn't respond, then try it again in a few seconds, and then again in twice as many times, and then twice as many times, so that you don't overload the car service. And then once the cancellation is done, then it will just undo the hotel as well. So that's the compensating part of the Zaga. So when do we need to undo everything? So we read the Zaga log, and if we see abort Zaga in the log, that's a sure sign that we have to cancel everything, right? If there is an abort Zaga, we have to cancel it, but that's not the only case. Also, if there is a begin sub-transaction, so for example, begin hotel, and that's the last line in our Zaga log, then that means that we failed. At least if someone else has to pick up the log. So the way this works is your process is doing the Zaga, and then it fails at some point. For example, the process crashes, and the last thing it wrote was begin hotel. Then we don't know if the hotel is reserved or not. So what we are going to do is say we assume that it wasn't successful, and then we start compensating for everything. Okay? Yeah, and this is why idempotency is really important, because what we are going to do is we are going to try until we are successful with that compensation. Now there is another version of this pattern called forward recovery, and the reason that we need that other pattern is because sometimes some actions cannot be cancelled. For example, I work at a company that's sending emails. That used to be our core business. Now we do a lot of other things, but it's still an important part of our product. And when you send out an email, you cannot cancel that, right? Once it's sent out, it's sent out. So you need some other solution. And that other solution is forward recovery. So you have your Zaga, you do everything first that you can undo. And once you get to the part that cannot be undone, but can be implemented idempotently, you will start doing that. So in this case, sending the email is going to be our last step. And if that fails, then we will just go back and try to send it again. Now you might catch a bit of a problem there, because maybe we just didn't realize that sending the email was successful. But the trick is that since we are making this a really small operation, a really quick and small operation, we can minimize the probability of sending that email twice. It's never going to be 0, but it's going to be as small as possible. So that's forward recovery. And basically, the idea is to periodically retry with an exponential backoff. Yeah, I already talked about that. So now the only thing that we have to talk about is how we can achieve idempotency, because it's not always trivial, right? There are some actions where it's natural. For example, deleting an item or drinking the orange juice from the cup. That's idempotent by its nature. Once you have deleted something, if you try to delete it again with the same ID, it's not there, so you are just going to say, I didn't find that item, and then you know that it's deleted. So sometimes it's natural. That's a quick win. And in many cases, that's true. But in some cases, some actions might need to be made idempotent. So it's not by its nature. For example, sending an email. If you send an email twice, the person is going to get 2 emails and probably are going to mark you spam, and that's not good. So we want to make sure that we don't send that email twice, right? How do we do that? Well, for each action that needs to be idempotent and is not by default, we are going to generate a unique ID. And this unique ID will be what makes sure that we don't do that thing twice. And we have a nice diagram here. So what we are going to do is we have this request that's coming in. And what we will do, so notice that the actions that we are trying to make idempotent are always within one service. So now we can use a transaction. When we had multiple services, we couldn't use a transaction, but here we can use a transaction. And what we are going to do is we are going to start a transaction, insert ignore by unique key. So we have a separate table that just has one line for each completed action. Okay? And what we do is we are going to insert into that table, and we are going to use that unique ID as a key. And then if we have success, well, we have 3 options here. One option is that we get a unique key violation, which is good because it means that we already completed the action and we can just stop. That's a great thing. The other option is that we actually did insert the unique key successfully, and in that case we are going to perform the action, and if that's successful, then we commit the transaction and we are good again. Okay, so what happens here is that we had 2 queries. One just made sure that this is a unique operation, and the other one was the operation that we wanted to do. And then also if the unique key insertion wasn't successful, or the performing the action wasn't successful, then we just roll back the transaction and respond with a failure to the other service. And that way, we essentially made sure that that query just ran once. Does it make sense? Okay. So, wow, I've been quick. So, conclusion. What you need to think about. Okay. First, before I have my closing words, one really important thing that was pointed out to me by someone at a previous conference is that if you need the Zaga pattern, you actually have either you have a design problem with your microservice architecture because your service is doing too many things, or that service is really like a core item in your architecture. So in our case, where this issue came up, it was a workflow engine. So what you could do, you could draw up actions one after the other, and then it would be executed for you. And because this one service was essentially sending messages to all other services, we had really long-running sequences of these actions. And that's a valid situation for this kind of Zaga pattern. But context matters. And in many cases, and probably most of you will never need this, or at least not very frequently. But when you need it, then it's really useful. And if you have like something if you're building a service that talks to many other services, this is something you should think about. But again, context matters, and you shouldn't just run home and implement the Zaga pattern just because you heard about it. You really had to have a business case behind it. Okay, so that was the caveat. So what's great about the Zaga pattern is that it helps you think about the error case. So whenever you have a culture in your company that we are thinking of these kind of issues, we have to make everything idempotent, then it makes you think about the error case. And so when this whole thing, we found this solution. After that, for like a year, at every demo that we had, we were talking about this and how we solve these kind of issues. And by the time we finished making everything idempotent that had to be idempotent, I was the idempotence guy at the company. So whenever someone has this kind of issue, they always run to me. But yeah, so the thing is that where I want to get to here is that in our company there is already a culture that whenever you have an error case, you have to think about how you can handle that error case. What you should always do, whatever kind of service you build, is think of compensating actions. Always have some way to undo things. And one of the great, and also think about idempotency of actions. Can I make this action idempotent for other people who might be using my service? And the really nice thing that I realized was that GitHub, if you look at the GitHub API, they actually have a unique ID field for some of their actions. So you can send in a unique ID and they make sure that action is going to be idempotent for you. So it turns out that people at GitHub already knew about this and they were thinking of this. And what I want you to think about is this: whenever you build a service and whenever you build an API that other companies might be using, always think of how they can undo your operations. And if it's important that something happens once, then make sure that you accept an ID that they can send in, and you make sure that the operations happens only once with that ID. And basically, that's all I wanted to say. With one more thing is that I have, two things. Shameless self-promotion. I have a workshop called Lean Poker. It's great if you want to learn how to do continuous deployment and DevOps really well. Look it up. And I also have a YouTube channel called Morning Commute, where I discuss software topics with other developers in a car, like in a carpool karaoke, but we are not karaokeing, we are just talking. So you can look that up. And that's all I wanted to say. Thank you so much. Are there any questions? Yeah.
In your example with the booking agency,
Yeah.
one thing you may want to do is book the plane, the hotel ticket and the car asynchronously to speed things up. Can that work with the Saga pattern?
Yeah, it absolutely works. So the question was, can you do the operations in asynchronously? So you don't want to wait for each action to complete before starting all of them, and that's actually a possibility. The reason we didn't do that is because our application was in PHP, and doing asynchronous calls in PHP sucks. So we didn't do that. But if you work with Node.js, then it's perfectly a possibility, and you can wait for all the actions to complete. That's something you can do. One thing that you have to keep in mind, though, is that if you have a forward recovery part, then you have to first complete all of the actions that are compensatable, And only when those are done and all of them successful, then you start the forward recovery part. Because if you send the email, it's sent. Any other questions? Yeah. Uh, yeah. So one piece of advice: before you implement your own SAC, try to look for an open source implementation online, because it's not that difficult to implement it. It's like 200 lines of code, but if someone else wrote it, why not use that? Otherwise, I didn't use singleton. I personally think that singleton is an anti-pattern. So so we simply made sure otherwise that we have a single SAC for each process. The thing that you have to think about it is, if you have a Zagalog being written, you want to make sure that if another process finds that Zagalog, then it doesn't start working on it, right? That's the tricky part. And the way we solved that was that each Zagalog had a line that contained the process ID that last worked on that Zaga. And then what we did was that we had a separate process that will look through all of the open Zagas and see if the corresponding process IDs are still running. And if one of the process IDs wasn't running, then it would start a Zaga execution coordinator for that particular Zaga. But you have to make sure that the process that was handling that Zagalog has actually died before you start another one. That's a really good point. But there are several other ways to do it. I think in Java you would probably create a lock file and lock it, and then when the process dies, the Java process dies, it lets loose of the lock, and then you could do that. That's also a possibility. Any other question? Yeah.
Have you ever had performance problems when you're using the unique key insertion, because this has to be synchronized if you have more than one database or whatever?
That's the point, that you don't have to, because the okay, let me show you. So the whole thing that we have here, this is something I tried to point out, but maybe it wasn't completely obvious. But this thing is in one service. You don't have multiple databases here, because the whole point of the Zaga pattern is, if you have a long transaction with multiple services, you are breaking it up into smaller pieces, and each of these pieces is going to affect just one service. And since it is only affecting just one service, then when you want to make it idempotent, then you are just dealing with one service. Make sense? Okay. Anyone else? One in that case, thank you for your attention.